quantification of salt beds and anhydride beds as well. Now, many of you actually talked about the variogram processing. Okay, variogram processing, let me remind you, at least, or warn you a little bit, because it's a very tedious process. I will go through it, try to make it easy on you guys how to do it, because variogram, as I said, is not as easy as a histogram. But let me start. What is a variogram? Variogram is mainly trying to do some statistical evaluation of data based on the spacing between wells. When we talked about the histogramming before, histogram does not take into consideration the well spacing. Histogramming I can do for a single well, okay, or I can look at the variation across a well, but without including the spacing between wells. And that puts a drawback on using the histogram for characterization of multi-wells. We need to find a way to look at how these wells are characterized together as a function of how far from each other they are. Okay, so the variogram will give you this. So the variogram provides quantifications of the variations based on distances between wells. Okay, all right. So for example, let's just take a reservoir. Here is a reservoir. All right, and for the first one, here is our area. My area will be divided by x-axis and y-axis, defined by x-axis and y-axis. Each well will has an x location and y location. Okay, and also there is the z-axis where this is the depth. So every well will have a location on the xy plane, and also will have measurements on the z, which is the depth axis. Okay? And let's assume that here is the layer that you will actually interested in. Here is your reservoir, and your reservoir I'm interested in, for example, the variation of porosity across my field. I need to look at variation of porosity across my field. So here is my reservoir, here is my target, and I need to look how the porosity is varying across my field based on the distances between the wells. Okay, so let's just first of all, let's assume this here is my first well. Here is well number one. Well number one penetrated the reservoir, and here is my reservoir section, and here is my XY point. So this well is drilled in X1, Y1. So I actually decided the location of my well on the XY plane. So I have X1 and Y1 for the location. And also, I actually try to calculate the average porosity using histogram for a single well. So from the single well, I can put a histogram here, and I calculate my average porosity. I call it Phi1 for well number one. Okay, so I will use the histogram in every single well, and I get the average porosity using the histogram for this well. That doesn't, I don't need to go for X1 and Y1. There is no, it is only in the Z direction. So in the Z direction, I will calculate my average porosity using the histogram. Okay, so I did this for the first one. Then we decided to drill a second one. Second well would be in a certain location, X2 and Y2. So the second well is in a different location, penetrated my reservoir, and also I measured the porosity in the section that the second well actually intersected in my reservoir. And it gave me an average of Phi2. So the average of porosity in the first well is Phi1, average porosity in the second well is Phi2. Remember, these two wells has a certain spacing. So there is a spacing between the two wells. I can actually calculate the spacing. If I have X1 and Y1, and I have X2 and Y2, then I can find the spacing between these two wells, which is the square root of X1 minus X2 squared plus Y1 minus Y2 squared. So this is actually the distance D12, means the distance between well 1 and well 2. So D12 is the distance between the first well, well 1, and well 2, and I can calculate the distance between any two wells. Dij, whatever well I and well j, is actually x1 here minus x2 squared plus y1 minus y2 squared, or to make it a generic, xi minus xj squared plus yi minus yj squared. So I can actually get the distance. So now I have the distance between the two wells, and I have the average of my porosity for every well by itself using the histogramming for the first well and the histogramming for the second well. Now, let's assume I drill the third well. The third well now will have a location x3 and y3. Now, it also penetrated my reservoir, and I will be able to calculate with the histogramming my average porosity P3 of the third well. So now I have three wells. What are the combination of distances in this case? First of all, I got the distance between x1, y1, and x2, y2. I already have these two, and then I have to go x1, y1 with the x3. So the distance between x1 or well 1 and well 3, and the distance between well 2 and well 3. So now I will have three distances, all right? So the second distance is the distance between 1 and 3, d13. I will go, I use this equation, dij, to calculate the distance d13, will be the square root of x1 minus x3 squared plus y1 minus y3 squared. So I got the distance between these two wells. Again, there is another distance between well 2 and well 3. I will call it D23. D23 is the distance between 2 and 3, which is simply x2 minus x3 squared plus y2 minus y3 squared, and I take the square root. So I can actually decide the distances between all wells, okay? And also I use the histogramming to get the average porosity for well 3, average porosity for well 1, average porosity for well 2. So now I will build a certain table. That table goes into what is the distances between each well, each two wells, and also what is the average porosity for each well. Okay, so I'm collecting data now. All right, then I will say, okay, there is something we will define called the variance. Variance or gamma. What is the gamma? Well, phi1 is different by phi2. For example, the average porosity here is 20 pu, but the average porosity here is 18. All right, the average porosity here is 17. So what you do is, once you calculated d12, which is the distance between 1 and 2, you actually get the difference between porosity 1 and porosity 2. So you say phi1 minus phi2. Here is the difference, all right? And you make it square, because we don't want to, if phi1 and phi2 or phi2 minus phi1, it doesn't matter. If you make it square, you will actually take care of the negative sign. So it will be phi1 minus phi2 square. So I got the distance d12 and the variance of the porosity between phi1 and phi2. Then I calculate the distance d13 and I get the variance between 1 and 3. Phi1 minus phi3 squared. Then I get the distance between 2 and 3, which is d23, and the variance between phi2 and phi3, which is phi2 minus phi3 squared. You add all these variances, you divide them by the number of wells, and you take the square root. We call this a variance. So here is actually the variance gamma, which is a function. You get the differences, how the well is different from that well. You go for phi2 minus phi1 squared, phi2 minus phi3 squared, phi1 minus phi3 squared, and I add them up. Then I take the square root of all and I divide them by the number of wells. So you add up the variances, you sum them up, you divide them by the number of wells, and you take the square root. We call this variance. Okay, right. That's a very simple example. Actually, in reality, what we usually do is, here is how we do. P1 and P2, we get the difference squared. P1 and P3, you get the difference squared. P2 and P3, you get the difference squared. You sum all the differences. You divide them by the number of wells, and you take the square root. It gives you the gamma. Okay. Right. It gets more complicated now if you go to reality. Reality is, okay, once you finish this, you go for the distances versus the variance. So now we have distances d1 to d1, d1, 3, d2, 3, and so on. So you get the distances versus the variance. So you calculated the first distance versus variance, second distance versus the variance, and so on. You plot them distance versus variance, and you get the relationship. Now, as you can see, these three wells, okay, as an example, they are in correlation. You can see it's actually increasing. How at this well, it's off correlation. So we call this distance is correlation. It exists between this well and this well is off correlation. So I can look statistically, where is the distance that's off correlation different than the other part of the reservoir, and where are the reservoirs that are correlated as a function of distance to variance or variation. That's why we call it variogram, the variance as a function of distance. Okay. Okay. Let's just do this in real example. Here is a real example. I have actually multiple wells here. How many wells? I have about 16 wells. So the number of wells, actually I have 16 wells. So the first step is to list all wells location and the property of interest. Okay. For example, I have well 1, 2, 3 up to 16. Every well has an X and Y. So this is the X for well 1 and Y for well 1, X for well 2 and Y for well 2. And I'm interested in porosity. So this is the porosity of well 1, 2, 3, and so on up to 12. So I make a list of all the data I have. Well 1, X and Y, and porosity. You can do that for porosity, clay volume, water saturation, permeability, whatever you like. You can do variogram for any property that you want to do for. So the wells, X location, Y location, and the property. Okay? So this is the first thing you need to do, is to list down all of these wells. Okay? Then you create a table of all possible well distances. It means the well distance is xi minus xj squared plus yi minus yj squared. That will take the square root. These are the distances. No repetition. It means the distance between 1 and 2 is the same as the distance between 2 and 1. So you don't go and calculate distance between 1 and 2. Then you calculate it again as 2 and 1. It doesn't make any sense because the distance between 1 and 2 is the same as 2 and 1. Okay, so it's either you use 1 and 2 or you use 2 and 1. Okay, so that's why we call it no repetition. You don't repeat it. Okay. Second, meaning the distance ij is the same distance ji. Okay. Mathematically, how many combinations you will have? Okay. It's actually mathematically it's n plus n times n minus 1 divided by 2. What is n? N is the number of wells. As I told you guys from the beginning, it's a very tedious process. So because it's a lot of combinations that you need to look at. N is the number of wells. So number of wells is 16. Then 16 times n minus 1, which is 15. 16 minus 1 divided by 2. It gives you the total total number of combinations that you may have between all the 16 wells or any number of wells. So in this case, the number of wells is 16. So how many combinations between distances I have in these 16 wells? Sure, look at this. Only 16 wells. Sometimes we have 300, 400 wells. Look at how many combinations that you will have, thousands. Okay, so it's a number of wells here is 16. How many combination of distances I will get between the 16 wells? First of all, it's actually 16 plus 16 times 15, n times n minus 1 divided by 2. You have 136 combination of distances and variances. Okay, everybody understand that? So in this case, you will have a lot of correlation that you need to build tables for, and you see the variability of it. As you can see, is much harder than what the histogram is all about. Okay, so you look at the combination of distances and the variance between all these distances. Actually, the way we do it is to build a table. A table has X, which is 1, 2, 3, 4 up to 16, and you can do that on Excel, and also the Y 1, 2 up to 16. Okay, here is the wells that well by itself 1 and 1. 1 and 1, the distance is 0, so it means there is no. These are the wells by itself. Then I have well 1 with well 2. We call it D1, 2. Well 1 with well 3, so D3, 1, D3, 2. Well number 4 was 1, D4, 1. Well number 4 was 2, well 4, 2. I don't fill the other part because it's going to be 4, 3, 2 is the same as 4, 2, 3. So it doesn't make any sense to fill the upper part. We only fill all the possible combinations between wells. So this, for example, here, well 6. Well 6 will have a distance between 6 and 1, distance between 6 and 2, distance between 6 and 3, 6 and 4, 6 and 5. And you go to well 7, 7, 1, 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, and so on. Okay? Then you fill this. If you do this in Excel, it will be an easy thing, but you know, this is how we fill it. If I do it on Excel, here are all possible distances based on the well locations I have. As you can see, huge type of calculations that you need to decide 136 spacing between the 16 wells. So the 16 wells created 136 spacing. Okay, all right, all right. Once you did this, then you have to do what? You have to list all possible combinations in tables. For example, I can see here well one and the order is well 1 and well 2, well 1 and well 2, well 3 and well 1, well 4 and well 1, and so on, until you go for well 16 and well 1. Then you have to well 1 to well 2 and well 1 and well 2 and well 2 and so on. So you have all these possible distances between wells. Okay. For example, here is the possible distances for well 1. Here is possible distance for well 2, and so on. Possible distances for well 3. So you take it a well by well. So well 1 will have a distance between 1 and 2, 1 and 3, 1 and 4, 1 and 5, and you list the distances. Then well 2 will be 2 and 3, 2 and 4, 2 and 5, and you list all the distances. Well 3 here, 3 and 2, 3 and 3, 3 and 4, 3 and 5, and so on. Okay, so you will have all these possible combination of distances between wells. Okay, so you list them all. Okay, then arrange them. Arrange the distances from low to high. For example, here are the distances of 0 means the well on itself. Then distances will increase here. This is 200, this is 205, 281, 300, 370. You can do that easy again on Excel, because Excel can arrange things ascending or descending. Okay, so you arrange all the distances from the 0 all the way to the maximum distance that you have. Once you do this, here is the 0 distances, here is distances increasing this way. Okay, so here is 0 distance means the well on itself. So the well will have its own variances with itself. Okay, then once you do this, so you have now you decided what is the distances between wells. Then you go do whatever you used to do with the histogram, which is the range of the data. What is the range of the data? The minimum value of distance and the maximum value of distance. Minimum value of distance will be 0. Here is the minimum value, and here is the maximum value. So we have the minimum value and the maximum value. We call this range. So the range will be the maximum value we found from the data is 2100 minus the minimum value is 0, so the range is 2100. Now we divide the range into bins. Remember that from the histogram. We divide the range. Now, what is the range? Range is the distances between wells. That's how now we combine the distances with the histogramming. So the histogram now will take care of the distances, and we see the variances between the different wells. So here is the number of bins, let's say 10 bins, okay? And you decide on the range. How can I get the range? You divide the range on the number of bins that you decided. Then each bin will be 233 distances, or 233 meter, or whatever the distance that you're measuring. Okay. Then you list all these ranges in bins, like with exactly what we do in the histogram. So look at here. Here is bin number 1, bin number 2, up to bin number 10, because you decided that the number of bins are 10. Here are the distances of the bins, and here are the range of each bin. Okay. Remember, when we take actually the range, we decide on what is each one of these bins will be. Here is bin number 1, bin number 2, bin number 3, and so on. So actually, as we used to do for the histogramming, and also we decide for the midpoint of each one of them. All right. So we have actually defined the bin and the middle of each bin. Right. Once you do that, I know it's, as I told you, it's a very tedious process, but it's simply because you can see a lot of calculations here. And I'm just taking a very simple example, a field that has 16 wells. Now, if you have 300 wells, imagine how many calculations you will do. Softwares actually do that for you, but that's how the softwares work. So in case the software does not give you the proper distribution and you feel something is wrong, so you know exactly what went wrong with the softwares, and you go back and you look at your data one more time. Okay. So let's just continue on this. You actually decided on the bins, and here you have each bin minimum and maximum, and also the middle of each bin. Okay. Once you decided on the start and the end of each bin, you look at the number of wells in each bin. The number of wells here is 16 in the bin number 1, Number of wells here is 7, 25, 26, 23, 18, and so on. So you have 7 wells that actually lies between these two ranges. So the distance 116 to 350, I have 7 wells that has these distances. I have 25 wells that has distances from 350 to 580. And I have 26 wells from 580 to 816, and so on. So I now decided number of wells that goes within this range of distances. Okay? Once you do this, then you calculate the variance now. Variance is phi I minus phi j squared. Remember porosity here. Porosity from well 1 minus porosity well 2 squared, and you add them up, and you divide them on the number of wells. Then you take the square root to get the variance. Once you got the porosity and the distances, you calculate the variance for every single group of data. Because the variances here is 0 between themselves. And if you go to the second group, you calculate the variance here between phi1 minus phi2, phi3 minus phi4, 5 minus 6, 6 minus 7, and so on. You sum them up, you square them, you sum them up, and you divide them by the number of wells, you get the variance. If you do this, for example, here is 12.7 minus 15.8 square. 7.6 minus 15.2 square, 11.9 minus 7.6 square, and you sum them all up, and then you take the square root of sum divided by the number of wells, which is 7 wells in this case. Okay, so you get the variance. You repeat this for all of them. Okay, here is another example of other group of data where you calculate also the variance as 14.05. Okay, then you finish all bins, and then you list them. Here is the distance versus the variance. Then you start plotting distance versus variance. Here is your distance, and here is your variance, and you can see all these are in correlation, and these are off correlations. Okay, so wells in correlation, wells are off correlation, as we saw in the previous example. And then you say this is wells off correlation, these are wells in correlation. Okay, so only wells with distances less than 1400 feet are wells in correlation. So now we can see the wells that has correlation together has to be within certain distances, and the other exceeding these distances will be off correlation. But you cannot actually find this from any type of histogram. Okay, as I said, this is a tedious process, but the whole idea is to look at to try to combine all possible distances between wells and the variation between the parameters between wells, and you start build the correlation between distance and the variance of the parameters, and that's what we call the variogram as a function of distance. Okay, right? Actually, I'm done with these 3